Hi everyone, welcome to day 4 of Unit 3. Phones should be in the caddy. If they're not there yet, if you could please put them in. Day 4 is our homework for tonight. You can be putting that in your planner. As you're taking your homework out for us to go over shortly, please also take out your compass and straight edge. We will be using those today. And then lastly, we have a warm-up to try. So we're going to pause the video for 4 minutes to allow you to take your packet and your um, compass and straight edge out to write your homework in your planner and also to give the warm-up a try on the warm-up sheet. So if point D is on the angle bisector, it is equidistant from the sides of the angle. And when we measure distance, we measured at a right angle. That's why those right angles are there. So the equation that we can set up is that 12 is equal to x squared minus 4x. And now we've got an equation that we looked at solving the very first few days of school. We'll subtract the 12 over to get everything on one side so it's equal to 0. And we want to do that because it's a quadratic equation, meaning it has the x squared. Our riddle we want to ask ourselves is multiply to negative 12 and add to negative 4. The two numbers that will do that are negative 6 and positive 2. So we'll have x minus 6 times x plus 2. Make sure you carry your equals 0. Also make sure you're showing your work that you're setting those each equal to 0. And then we'll solve for x. So we end up getting x equals 6 and x equals negative 2. Now when you get multiple answers, you want to make sure that they check out. The only expression we have to sub in is on the right. And if you do 6 squared minus 4 times 6, that would give us 36 minus 24, which that will give us 12. That checks out. And then if we do negative 2 squared minus 4 times negative 2, notice I'm always subbing it in parentheses. That becomes super important if you're subbing in a negative and you're doing it in the calculator. We need that negative to be squared as well. So this would end up giving us 4 plus 8, which is also 12, so that checks out. So we end up having two answers, and notice we just want to find the values of x, so they both end up working out. You can stick your warm-up away and moving over to our homework. Based on these arcs, that tells us those little angles are congruent, meaning LJ is an angle bisector. If J is a point on the angle bisector, we know it's the same distance from each of the sides of the angle. That allows us to set those two expressions equal to each other, go through and solve, we get x is 12. They also wanted to know what JK and JM were, so sub those back in and we happen to get 17. Going down to number 2, we've got our little arcs that show those angles are equal, meaning VT is an angle bisector. If T is on the angle bisector, it is equidistant from the sides of the angles. Set those expressions equal, we get y is 3, sub back in to get 15 for each ST and TU. For number 3, we want to know how is HL related to the angle? Well, notice L is equidistant from the sides of the angle. So that means that HL must be the angle bisector. If it's the angle bisector, that means we can put our arcs on these individual angles. The arcs signify that they are equal. So set those two expressions equal and go through and solve, and you end up getting y is 9. Looking at 4, we've got the right angles, but point A cannot be on the angle bisector because the distance to the one side is 8 and the other side is 9. Point A is equidistant from the sides of the angle here, so point A would be on the angle bisector. Going down to 5. 5A, it's kind of hard to see, but there's the little arcs there, meaning those angles are equal, so GM's an angle bisector. If M is on the angle bisector, it is equidistant from the sides of the angle, so we can set those expressions equal to each other and solve. You get x equals 7, and then they wanted us to sub in to find Km, which was the 5x minus 8, so we end up getting 27. Pretty similar idea here. We had the arcs, meaning we have an angle bisector, so M is on the angle bisector, so it is equidistant from the sides of the angle. So set those equal, you get 2/3 for x, sub back in to the Km expression, and you get 8/3. Alrighty, we're going to be over on page 20 for our new material for today. We're going to look at medians in a triangle and altitudes in a triangle. Again, we will need our compass and straight edge, so please take those out. If you happen to forget yours at home, there are ones on the front table, but make sure to put it back in the bin at the end of the period so we have them in case people forget them in the other periods. So first off, a median. A median of a triangle, it has one endpoint at the vertex, and in that first blank there, the other is at the midpoint. So just a rough sketch. If this is the midpoint, and I can signify that that is the midpoint by putting my tick marks, the median would go from the opposite vertex over to that midpoint. So that blue segment I just freehand drew in is the median. Well, in order to construct the median, we would need to know where to connect the vertex to on the opposite side. In order to find where to connect the vertex to, we would have to find the midpoint. Well, we can find midpoints with our construction tools when we do the perpendicular bisector. So what we're going to do is with our compass, we're going to bisect one of the sides. And in the instructions here, it doesn't specify which one we have to bisect. So I'm just going to do this bottom one. On the homework, it will specifically tell you to do the median from a certain vertex. So whatever vertex it tells you to do it from, you need to bisect the opposite side. Here it didn't specify that, so we can do any. To do the perpendicular bisector of a segment, put your point on one end point of the segment. We open our compass more than halfway. We swoop it up and down about a half circle. And then we reverse it. We put our point on the other end point of the segment. We swoop it up and down until we get two intersections. Then we'll move over to our straight edge. With your straight edge, we'll connect those two intersection points. It's up to you if you want to extend it beyond those, but we need to at least connect the intersection points. Where that crossed the side of the triangle that we were bisecting, that's our midpoint. And then we have one last step to do the median. We've got to connect from the vertex that is opposite that midpoint and connect it over to that midpoint. So that last segment I drew in, that's actually what we were looking for, the median. The median has an endpoint at one of the vertices. Vertices is just the plural for vertex. And then we've got one endpoint on the midpoint. On the bottom there, it asks if our median could be located outside of the triangle. Well, if it has to go from the vertex and go to the midpoint of the opposite side, the only way to get there is to travel through the inside of the triangle. So for this one, do we think it could happen? No. We'll say vertex to midpoint will always be inside the triangle. And it's the same explanation for the second part there. Could it be on the side of the triangle? Can't be on the side of the triangle. If you're going from the vertex to the midpoint, it'll always travel through the inside of the triangle. If we go over to the next page, could the median divide the triangle into two congruent triangles? Well, if we think of different types of triangles that there are equilateral triangles that have all sides the same. You have isosceles triangles that have two sides the same. And then you have scalene triangles that don't have any sides the same. So we could have in an equilateral triangle, I'm going to signify it's equilateral by putting the tick marks on all of them. Your median, if we're going to the midpoint, would split it into two congruent triangles. They'd be exactly the same. And this would also be true if we had an isosceles triangle. An isosceles triangle has two sides that are the same length. If I did the median from that angle up on top, which is called the vertex angle, then those two triangles would be the same. So we'll say yes in an isosceles and equilateral triangle. Isosceles, again, is when there's two congruent sides. Equilateral is if all three sets of sides are congruent. We're going to skip question 4, and we're going to go down to the bottom to our second thing we're going to look at today, which is the altitude of a triangle. The altitude of the triangle in that blank there is the perpendicular segment from a vertex to a line containing the opposite side. Perpendicular means it forms a right angle. Now, the way I always remembered altitude when I was in high school was a common place you hear altitude used is when flying on an airplane. The captain comes on and says, we're going to be cruising at an altitude of 30,000 feet. Well, that's 30,000 feet measured straight down to the ground at a right angle. It's not measuring it at a diagonal towards like the city you're going to or something. It's straight down to the ground at a right angle. So that's how it helped me remember, okay, altitude goes from the vertex and forms a right angle. So I'm going to draw on this triangle here for a second. Don't draw what I'm about to draw. I just want to show you something, just freehanding. If we were going to go from here and we wanted to do an altitude with the other side, it would roughly look like that and form a right angle. So again, don't draw that on your paper, just kind of follow along. I'll tell you when you can start drawing what I'm doing. If we went from one of the other angles though, let's say we went from this angle up here. There is no way to draw a line that goes through the inside, so it forms a right angle here. So what sometimes happens with the altitude is you extend the side, and then now from here you could draw our altitude in that does form a right angle. So just from this idea, the follow-up question we had before with the median, that it's always inside the triangle and could never be outside, This basically shows that sometimes your altitude will be outside of the triangle. So what we're going to do is we're going to actually construct the altitude. So now you can start writing and doing what I am doing on here. Because our altitude is going to extend outside the triangle, first thing we want to do is we're going to extend this side of the triangle. So we'll do that with your straight edge. So either if you have a ruler or a side of a protractor or just your calculator cover, go ahead and extend the side of that triangle. And we're specifically doing our altitude from this point here, but you could do it from any of the points for this problem. On the homework, it'll tell you specifically which vertex to do the altitude from, and you'll always then work with the side that's opposite that point in the triangle. So what we're going to do is we're going to do our perpendicular line that's not on the line construction that we saw in Unit 2. So let's take our compass. We're going to put our point on the vertex of the triangle, and we're going to open our compass so it goes beyond the line that's the opposite side. And our goal is to make an arc that will hit the opposite side in 2 spots. So I'm going to make an arc, and notice it intersects that side in 2 spots. If you didn't extend your line long enough and your arc goes too far to the left, just extend your line now with the straight edge. That's perfectly fine. Well, now what we're going to do is we're going to use these intersection points of the arc and that side that was extended. And we're basically going to use those as the endpoints of a line segment, and we're going to do our perpendicular bisector now. So I'm now going to put my point on one of those intersections, and we've just got to be open more than halfway. And what I'm going to do is I'm going to do my half circle swoop up and down from one of the intersections of that original arc. And then I'm going to reverse it. I'm going to put my point on the other intersection of the original arc, and keeping my compass the same, I'm going to swoop it up and swoop it down. Where those 2 arcs intersected, so for me that's here and here, we're going to connect those with our straight edge and then extend it till it hits the vertex. So with my straight edge, I'll extend those and keep it going through until it hits the vertex. And this is our altitude. It started at the vertex here, and it now makes a right angle with the extension of that opposite side. Sometimes you might not have to extend it, but sometimes you will. And you can hopefully kind of eyeball and see if there's a line that can come from the vertex and form a right angle inside the triangle, or if you're going to have to extend it. Can the altitude be located outside the triangle? Yes. We just saw that in the example. And we want to know, can it be on the side of the triangle? Well, that is going to be true if you're starting with a right triangle. If we were going from this point here and we wanted to form a perpendicular line with the opposite side, the altitude is just going to be right on top of the side because the right angle is already there, and that's what we want. So yes to the first one, and then yes to the second one. For the second one, if it's a right triangle. And notice the type of triangle in our example on the other page was it was obtuse. This angle right here was an obtuse angle. And if you have one obtuse angle, then that's an obtuse triangle. And we'll summarize that in some notes on the next page as well. Can the altitude divide your triangle into two congruent triangles? Well, it's the same idea with the median. This is going to be yes if it is equilateral or isosceles. And just so you can get a visual, here's our equilateral triangle roughly. I'm representing it with the tick marks. If I go from any vertex and draw the altitude, it's going to split the triangle into two triangles that are identical. If we look at an isosceles triangle, which has just two congruent sides, if I do the altitude from that what's called vertex angle, that'll also split it into two congruent triangles. So we're going to skip number 8, just like we skipped that one on the other one. And we're going to go over to page 23 on the top. And this just summarizes when the altitude will be inside versus outside versus on the side of a triangle. So the first one, it'll be inside anytime we have an acute triangle. It will be on the side, we mentioned on the previous slide, when we have a right triangle. And the altitude will be outside when you have an obtuse triangle. For the next one, could the altitude and median be the same? Well, remember we saw in some previous problems that the altitude and the median could both divide the triangle into two congruent triangles. Well, in those cases, they would be the same segment. So here's our equilateral triangle, and here's a random isosceles triangle. The midpoint of the opposite side will also be the location where a right angle would be formed. Same thing here. If I did the midpoint of the opposite side, that would also be the location of where the right angle would be formed. So the altitude and the median would be exactly the same. Can the altitude and the median of the triangle be parallel? Well, parallel lines can never intersect. Because the median and the altitude are both coming from the vertex always, they're always going to intersect at the vertex. So therefore, they can never be parallel because they're guaranteed to intersect there. So no, they will always intersect at the vertex. Now, one of the trickiest things is sometimes picking out how things look in a picture from markings. So that's what we're going to do on the next page. We're going to write down and show as a visual what we would want to look out for when working with each of these different things. If you have a perpendicular bisector, so perpendicular means there's right angles. Bisector means you're going to get two congruent segments. So what we would want to look for is we'd want to look for congruent segments and a right angle. And we're going to draw an example here. So here's my midpoint, and I'll signify it by marking those congruent segments. And if I draw a line at a right angle that goes through that midpoint, that would be our perpendicular bisector. It's got a right angle as it passes through the midpoint. Notice it does not necessarily go through the vertex. This is our only one that does not go through the vertex. For the angle bisector, an angle bisector splits an angle into two congruent smaller angles. So to recognize an angle bisector in a picture, you want to look for congruent angle markings at a single vertex. And we'll show you an idea of that over here. So let's say you've got some line coming from a vertex. If you see the arcs for congruent angles, then you know that red line there is a angle bisector. The markings of the angles tell us that it's an angle bisector. An altitude starts at the vertex and makes a right angle with the opposite side. So you want to look for a line from the vertex that makes a right angle with the opposite side. We'll draw a little picture of that. So if we wanted to go, actually let me make that a little more slanted. Oops. There we go. So if I wanted to do an altitude from this one here, we'd have a line coming from the vertex, and it forms a right angle with the opposite side. And then the last one, the median, goes from the vertex to the midpoint of the opposite side. So we've got a line from a vertex to the midpoint of the opposite side. And we would know that it's a midpoint because there would be two congruent segment markings. So we'll draw an example of that. If this was the midpoint here, we would signify it's the midpoint with the tick marks. So the line that comes from the vertex opposite that would be our median. So that green one would be considered a median. So we're going to use this to help us on the bottom of the page to classify either as a perpendicular bisector, angle bisector, altitude, median, or none. And we're looking at segment AB for all these. So in this first one, AB goes from a vertex and it forms a right angle. If it's got a right angle, it's only two options. It's either the perpendicular bisector or the altitude. Perpendicular bisector makes a right angle at the midpoint. Altitude starts at the vertex and makes a right angle with the opposite side. And it could be that side extended. Well, notice B is not at the midpoint. There's no congruent segment markings. So therefore, AB here is an altitude. Here's A, B in this one. We're starting at a vertex. And B, notice these congruent segment markings. Because of the congruent segment markings, that means B is a midpoint. So our one that goes from the vertex to the midpoint, that's just our median. In C, notice AB does not start at a vertex. So that rules out angle bisector, altitude, and median. Perpendicular bisector, though, has to have a right angle involved. There's no right angle here, so this would be one that's just none of those things. Here's AB. Notice AB again is not at a vertex at all. So the only one it could potentially be is a perpendicular bisector. Well, notice point A is the midpoint based off of those congruent segment markings. And at the midpoint, there's a right angle. So this would be our perpendicular bisector. And if you didn't want to write the whole perpendicular word, you are free to use our perpendicular symbol, that upside down capital T. AB in our next one, notice it comes from the vertex, and we've got these angle markings that they're congruent. Well, if you got those congruent angle markings happening in those smaller angles on the vertex, this is just an angle bisector. And for our last problem for this video, here's AB. We've got a right angle, so we would want to think either altitude or perpendicular bisector. The altitude needs to start at a vertex, which AB does, and then forms a right angle with the opposite side. AB does not go through the midpoint of a side, so this would be our altitude. So you've got day 4 homework to work on. You've also got problem set you can be working through as well. That's it for this video. Any time left in the period, you can work on your homework, and have a great rest of your day.